Afternoon. I'm going to take you through today the Edexcel core practical on resistance of a wire. So yeah, enjoy. So this is what we're going to start with. We've got our power pack over here, connected up with some wires, as you can see, running down here to a piece of wire which we've fixed to a meter ruler. That's just so that we can easily measure the length of that wire, and then it's connected back by a crocodile clip up here, all the way down these wires, back to the power pack. So we've got a complete circuit. Now, so let's have a look at how we're actually going to take our measurements in this experiment. So this is the diagram of the circuit we're going to build. We've got our power pack. I mean, I've drew a battery here, but power pack wire is just the same. We've got our wire coming around, connected by crocodile clips to a piece of thin wire. And then we're going to need to take, to calculate the resistance of the wire, we're going to need the current measured in amps, so that's an ammeter. And as you can see, that's connected in series. And then we've got a voltmeter to measure the potential difference, and that is connected in parallel. So I'm going to add them into the circuit now. Here's my ammeter. Just unplug these and plug this in its place, in series. And then the part that I actually want to measure the voltage of is the part between the end here and where the crocodile clip goes. So I'm going to plug in a wire to the end, and I'm going to plug in another piece of wire into the crocodile clip. Okay, so I've got my crocodile clip set at 10 centimeters. Move these out of the way so we can see a bit clearer. So that's 10 centimeters. There we go. Turn on my power supply. And straight away you can see that I'm getting a couple of readings. I'm getting, now it's warming up, 0.41, 42, 0.42 is the current. And my voltmeter is 0.36 volts. And all I'm going to do now is move that along another further 10 centimeters. My current is 0.33. and 0.54 on the voltmeter, and I'm just going to repeat this until I've done about 60 centimeters. Okay, so now we've got our results, we need to just do some quick processing. The first thing we need to do is calculate our resistance. And you should remember that from Ohm's law, voltage is current times the resistance. That is an equation that you're required to remember for your exam, so you need to learn that one. Now, if I want to rearrange that to get the resistance, I need to divide both sides by I, and that gives me the rearranged result. Resistance is voltage divided by current. So if I apply that to my results, all I need to do is divide this number by this number all the way down. So I'll just whiz through doing that now. And I'm going to round these to a sensible number of significant figures. These are all 2 significant figures, so I'm going to do the same for the resistance as well. So I'm going to need to plot my results on a graph, and looking at my results, I can see that my highest resistance is 4.7, so I'm going to have to go up to at least that high, so 5 on my graph, and my highest length is 60, so I need to go that high as well on my graph. So let's do that now. So I'll plot my points on here. Let's see how we do. So my first one is 10 and 0.86, so that's roughly there. Next one's 20 and 1.6, 30 and 2.3, 40 and 3.1, 50 and 3.9, and then 60 and 4.7, which is about there. And for now, this one I agree with the maths department on. This is definitely a straight line of best fit. You can definitely see that, can't you? If I, there we go, get my line as close to as many as I can. You can see I get a nice straight line. And you can see that, but what's happening essentially is that as my resistance increases, no, this is my length in centimeters, and this is my resistance. I nearly forgot to label my axis in ohms. And hopefully what you can see is that as my length increases, my resistance increases, and in fact, it's almost proportional as well. It looks like basically as I double my length, I double my resistance too. Okay, so that's our core practical.